Hello my dearest students. How are you doing at school? I am Professor Albert Einstein and would like to welcome all of you attending this lesson. I hope that you enjoy this session. I am sure that my explanation will help you understand better today's topic. Today, I will be talking about similar triangles. In general, similar figures are those figures with the same shape. When figures are similar, the corresponding angles of each triangle are all equal to each other. Furthermore, the ratio of all corresponding lengths in each triangle are equal. During this lesson, we will focus on the three different conditions that exist in proving that two triangles are similar. First, if the three angles of one triangle are equal to the corresponding angles of the other triangle, then both triangles into consideration are said to be similar. Let us follow an example to illustrate this better. Consider triangle HIJ and triangle ABC. If angle H is equal to angle A and angle I equal to angle B, then angle J must be equal to angle C. This follows geometrically, because all angles in any given triangle add up to 180 degrees. In a case like this, both triangles HIJ and ABC are said to be similar. Is that clear? Secondly, if all pairs of corresponding sides of two triangles are in the same ratio, then both triangles into consideration are said to be similar. Let us follow an example to illustrate this better. Consider triangle HIJ and triangle ABC. If you look at the figures carefully, you should notice that the length of sides of triangle ABC are double those of triangle HIJ. In other words, all sides are in the ratio 1:2. Since all sides are in ratio, then both triangles must be similar. Did you understand? Finally, if two pairs of sides of two corresponding triangles are in the same ratio, and the included angle of both triangles are equal, then both triangles are considered similar. Let us follow an example to illustrate this better. Consider triangle HIJ and triangle ABC. If you look at the figures carefully, you should notice that the lengths of HI and HJ are in ratio with the lengths of AB and AC, respectively. Furthermore, angle B and angle R are exactly equal. These two conditions qualify both triangles to be similar. Oh gosh, that should be crystal clear. Am I right? Well, let me check how much you have learned so far. Let us try to apply similar triangles in real life. That should be interesting, shouldn't it? As a first example, imagine that I would like to measure the vertical height of the Big Ben, which you can listen every now and then. How would you go about that if you cannot actually climb the watchtower? Okay then, let me explain. By the way, we can solve this by using similar triangles. Did you think of that? Right. If Follow the illustration on the side while I explain the calculation. So, consider you are visiting the Big Ben with a friend who is 2 meters tall, and you decided to measure its vertical height. Let your friend stand some distance in front of the watchtower. Let us call this position E. Then, with your eyes level to the ground, some distance away from your friend in a straight line, find the point at which you can see your friend's head, coinciding with the topmost part of the watchtower. Let us call this point C. As you can see, we have formed 2 triangles, ABC and CDE. By simple geometrical properties, we can easily prove that both triangles are similar. Then, from the previous lesson, we can conclude that all corresponding sides are in ratio. Therefore, the ratio of BC to CE is equal to the ratio of AB to DE. If you know the length of your foot, then you can easily measure distance CE and CB. Finally, through simple cross multiplication, we can easily calculate AB. Isn't that amazing? Yes. So let us have a look at another real-life problem which involves similar triangles. Imagine that you go for a walk by the river bank. At one point, you decided to calculate the river width without actually measuring it. Did you ever think of solving that by using the properties of similar triangles? Right. Follow the illustration on the side while I explain the calculation. Fix a point J on side of the river, a stone for example. Fix another point I on side B of the river, such that both points can be joined in a perpendicular line to the river bank. Fix a third point K on the same side of the river, some distance down the river. Go to the area of point M in such a way that you can see points J and K in the perfect straight line. When you are happy, fix point M by placing a stone. Fix the last point L in such a way that line LM is perpendicular to the river bank. Well, do you realize that we have set up 2 similar triangles? If you are convinced that both triangles are similar, then we can say again that corresponding sides are in ratio. Therefore, the ratio of IJ to LM is equal to the ratio of IK to KL. If you know the length of your foot, then you can easily measure distance IK and KL and LM. Finally, through simple cross multiplication, we can easily calculate IJ, the width of the river. Isn't that amazing? Well, I hope that you have enjoyed this lesson. And remember to apply similar triangles in your life. This movie was produced by Christopher, and obviously narrated by me, Albert Einstein. Thank you for your attention, and goodbye.